Monkey exponents and graphs. This is our last lesson in Unit 7. Okay, so number 1 says the value of an antique car is modeled by the function v of x equals 107,000, 1.09 to the 2/3 x, where x is the number of years since 2005. By what approximate percent rate is the value of the car increasing per year? All right, what should we circle? What are they asking for? What are they asking for? The percent rate. I heard Chuck say that. Percent rate. Circle that on your paper. That's what they're asking for, the percent rate. So based off of this function rule, which part gives me the percent? Very good. What's in parentheses? So mark out the 107,000. We don't need that. What is the 107,000? The starting value, okay? The y-intercept. So in your calculator, you're actually going to have to put in something extra today because they've put in an extra number. We've never seen that before. That's new, where there's an extra number. So in your calculator, you're going to type in 1.009, 1.009, caret key, 1.009, caret key, and what goes up high? Do you see it? 2 divided by 3, and press enter. Now, to get the percent, we always have to do something extra. We did it this morning on the warm-up. What do you have to do to get the percent? What? What do you have to do with this thing in your calculator? You got to do a step to get the percent. -1. Very good. So -1 and press enter. And multiply by 100. There we go. Now we're getting in our groove. All right. On your calculator screen, you should have 0.599 on your calculator screen. 0.599. All right. Raise your hand if you got that. 0.599 on your calculator. Good. So if you look at your answer choices, what does 0.599 round to? 0.60, which is C. Okay. So the first thing I did was I put 1.009 caret key to the 2/3 in my calculator, okay? And then I minused 1, and then I multiplied by 100. So those were the steps I took to get the percent, okay? All right. Number 2, the value of an antique toy car is modeled by the function v of t equals 5, parentheses 1.008 to the 1/2 t, where t is the number of years since 1985. Approximately what percent rate is the value of the radio increasing each year? Hey, keep looking for your calculator. All right, so let me call on somebody. How about Chad? What word do I circle? What are they asking for? Very good. Percentage rate. Chuck, which part of this will give me the percentage rate? The parentheses. So mark out the 5. So in my calculator, I'm going to put 1.008, and this time I have to do caret key to the 1/2 because they've put in an extra number with the percent. They've put in an extra number with the parentheses. 1.008 to the 1/2. So everybody type that in your calculator. 1.008 caret key 1/2. Monica, what do I have to do after I type that in? -1, press enter. And then Zaria, what do you do last? Times by 100 and press enter. Ethan G, what are you getting for the answer? 0.40, which is D, 0.40. Okay. All right. Question on 1 or 2? All right. Number 3, the value of a house in your neighborhood can be modeled by the function f of x equals 120,000, parentheses 0.92 to the 1/3 x, where x is the number of years since 1995. By what approximate percent rate is the value of the car decreasing each year? Andrea, what am I circling? Uh-huh. All right, Dylan, what are they asking for? What words should I circle? Good. So that's why I only care about these two numbers. Percent rate tells me to zoom in. Just focus on that. Just focus on that. Haley, after I type that in my calculator, what's the next step? Subtract 1, and then Ethan H., what's the last step? Times it by 100. Gracie, what are you getting in your calculator? So what does that round to based on your answer choices? 3, which is D. Guys, why is it negative? Very good, Dylan. It's decreasing. Okay. Number 4, the value of a diamond ring has been in your family for generations can be modeled by the function f of x equals 10,000, 1.002 to the 4/5 x, where x is the number of years since 1960. By what approximate percent rate is the value of the ring increasing in value each year? Jesse, what am I circling? That's not important in this one. What's it asking for? Good. It's asking for the percent rate. Jesse, which part of this matters for the percent rate? Very good. Okay. So everybody should be typing that in. Some of y'all have already done it. If not, should be typing in. And so you type in 1.002 to the 4/5, press enter, subtract 1, and multiply by 100. Let me have Ethan G. What are you getting? What does that round up to? He got 0.159. That rounds up to 0.16. All right, which is C. Okay. On number 1, guys, what is the 3? Starting value. What is the other word for starting value? Good. Label it on your paper. Everyone, I should see pencils moving. Label 3 is your starting value and your y-intercept. So where does 3 go on the graph? What? On the y. It's the y-intercept. It goes on the y. So this is the y. This is the x. So we put 3 on the y. 1, 2, 3. It's my y-intercept. Now, is this linear or exponential? Because it has a exponent, so it's exponential. Is it going to be a straight line or a curve? It's going to be a curve. Now, what does this 2 mean it's doing? It's timesing by 2. Does that make it get bigger and bigger or smaller and smaller? Bigger and bigger. If you're multiplying something by 2, it gets bigger and bigger. So this one's going to be a curve, and it's going to be going up. It's increasing. It's increasing. It's going up. Okay. All right, on the next one, Haley, what is the 2? What do I label it? Good. 2 is my y-intercept. So, Andrea, where do I put the 2? On the what? On the y. So I put a point at 2 on the y. Monica, if I'm multiplying something by 1/4, is that going to make it smaller or bigger? Smaller. And a way you can test that is you can type in 1/4 minus 1 in your calculator. You can type in 1/4 minus 1. Everybody do that. 1 divided by 4 minus 1. And are you getting a positive or a negative? A negative. What does that mean? It's going to be going down. It's going to be going down. So you can take this number and subtract by 1. So this one's a curve, but it's going down. This one's a curve, but it's going down. Okay. All right. Number 3, 5, parentheses 3 to the x. Gracie, what does the 5 tell you? Uh-huh. So, Chad, do I put the 5 on the X or the Y? Uh-huh. And Ethan, H, when it has a 3 in the parentheses, is going to be going up or going down? Good. Why is it going up, Ethan H? Yep. Well, if you subtract 1, it would still be positive. Yep. Okay. All right, number 4. Daniel, tell me about the 4. So I put a 4 on the Y. Okay. Very good. He said if you take 2 divided by 3 and you subtract 1, you get a negative. And so that means your curve is going down. Very good observation. Anything less than a whole number is going to be going down. Okay. All right. Now let's go back to the 2 we skipped. So don't flip it over yet. Let's go back to the 2 we skipped. All right, right here on this one, put the 5 to the X in parentheses. Put 5 to the X in parentheses. What number do I need to put out front? A 1. Everybody do that. Put a 1. So you need to be really careful on these. Is my starting value 1 or 5? 1. You have to put a point at 1. If I'm multiplying by 5, am I making it go up or go down? Go up. So I do a curve because it's exponential, and the curve goes up. Curve goes up. Okay, on this next one, is 1/3 my starting value? Because it's with the X. So put this in parentheses. Put the 1/3 to the X in parentheses, and I'm going to call on someone. Don't say it out loud. Jesse, what number do I put in front? A 1. Good. So Chuck, which one of those is my starting value? 1. And Chuck, if it's got 1/3, is it going to be going down or going up? What? Going down. Okay. All right, any questions on that? All right, flip it over. Okay, now they're going to kind of throw a wrench in things, throwing a wrench in it. See how there's an extra number on these? This number changes your starting value. This number changes your starting value. So what do we think the starting value started at? 3. Starts at 3. But then you have to subtract the 4 to actually get what goes on the graph. So let me say that again. This and this get put together for your starting value. You have to put them together. So what is 3 minus 4? -1. So your starting value is now -1 because they've added an extra thing to the graph. So your starting value is now -1. Now, the other rule doesn't change. You still look in the parentheses to see if it's going up or down. So what's in parentheses? 2. If I'm multiplying something by 2, is it going to go up or go down? If I'm multiplying something by 2, it's going to get bigger or smaller? Bigger, so it's going up. Another way you can test that is you could do, what is 2 minus 1? 1. Is it positive or negative? Positive. If it's positive, it's going up. Okay? All right, so number 6, for my starting value. Chuck, what 2 numbers do you have to put together for your starting value? Which gives you what? 5. 1, 2, 3, 4, 5. So I'm going to put a point at 5. All right. Andrea, for 1/4, does that make it go down or go up? All right, type in 1 divided by 4 in your calculator. And subtract 1 from it. Get a negative. All right, so that one's going down. Remember, you always start on the left, and so it's going down. Okay? All right, number 7, Daniel, what would be your starting value? Very good. You have to put the 5 and the -8 together. Gives me -3. Gracie, got a 3 in the parentheses. Does that make it go up or go down? Very good. This one's going up. All right, sorry, for number 8, what two numbers do you put together for your starting value? 4 and -4. So what's 4 minus 4? 0. So this one your starting value has a 0. So everybody put a point in the middle. And Monica, 2/3, is it going to be going up or go down? Going down. Questions? Okay. All right. This one, number 9. Number 9. Okay, this is the exam question they love to put on the test, all right? I guarantee you're going to see this on the exam at the end of the year. You've got this function right here. So everybody box this in, and I want you to write the word old with it. So this is the old function, 3 parentheses 1/2 to the x. Then they replaced this with the graph. So label your graph the new one. So this is the old function, and this is the new function. We have to figure out how they changed. So what was the starting value on the old one, Dylan? Yeah, so everybody put a point at 3 on your graph and label that point old because it came from the old function. So put a point at 3. All right. What does the 1/2 make it do? Go down. Is this one still going down, this new one? So we don't need to worry about the 1/2, okay? You don't have to worry about that because they didn't change that part of it, okay? Here's what they did change. So on the old one, its starting value was 3. Now let's look at this new one. Its starting value is way down here. Where is that at? Anybody see it? -6. So what they did was they shifted it, and we have to figure out how many blocks they changed it by. So we were here. So 1 block, 2 blocks, 3 blocks, 4 blocks, 5 blocks, 6 blocks, 7 blocks, 8 blocks, 9 blocks. They changed it by 9 blocks. Did they go down or did they go up if you started the old one? They went down. So K, that's just what letter they're using, is -9. This means down 9 blocks is all that means. Okay, so don't make it harder than it is. So K is what it changed by. So they shifted it -9, down 9 blocks. The old one was at 3. The new one's at -6. So you count 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. All right. Let's see. All right, good. We've got another one to do. So first thing I do, what is that one? What do I call that one? The old one. Okay. All right, what do you know about the old one? How? What do you know about the old one? Thank you. The starting value is 3, so we're going to put a point at 3, and we're going to label it the old one. Everybody do that. Put a point at 3, and label it the old one. All right. Where is the new starting value? At 2. Okay, so you go from the old to the new. That's the order you go in, old to new. So if I'm at the old one, how do I go? Down 1. And so how do you do down 1 in math? How do you call that? -1 is your answer. -1. Okay. So whenever it's asking for the K, that's when you do the old and new stuff. Whenever it's asking for the K. Okay. All right, last one. This one, a function is graphed below. Which of these could be the function? So what would be helpful to know from your graph? Very good. The starting value, which is also the y-intercept, where it crosses the y. So here's the y. Where does it cross at? Very good, Chad. negative 3. Okay, now this is kind of a challenge problem, so nobody get stressed about it. But some of my peeps in here are really kicking butt in class, so you need a good challenge every now and then. Okay, be careful. What is the starting value on A? Think, think, think. Okay, you're on the right track. I put this in parentheses, and I put a what here? A 1. Okay, keep thinking. And then I subtract 3. So what is 1 minus 3? Negative 2. Okay, what am I looking for? What's the graph have? I'm looking for negative 3. So is A the answer? No. Okay. Okay, let's skip to B. Okay, tell me about B. Put a 1. Subtract. And is that what I want? Yeah. So the answer is B. Okay. Well, you don't need to write this one down, but let me have Dylan read it. All right, so Jesse, what word should I circle? And Chuck, how do you get the y-intercept? Very good. Chuck says you have to plus 2 and 5. So Gracie, what does that give you? That one is C. All right, here's the on your own. And